Kuzampo, welcome to Bhutan e-learning project. I am Jambe Dorji. I teach mathematics in Motidang Higher Secondary School. I am going to take you through matrices. I have set the following objectives. At the end of the lesson, following topics will be covered. We will study the type of matrices, order of a matrices, operation with matrices, addition and subtraction of the matrices, multiplication of a matrix with a scalar, multiplication of the matrices, adjoint of a matrix and inverse of a matrix, application of a matrix multiplication. The last one, use of matrices to solve simultaneous system of linear equations in 2 or 3 unknowns. So, what is a matrix? Matrix is an array of numbers enclosed in a square bracket. In other words, matrix is a method to arrange and store the informations. The entries are known as element of a matrix. For instance, if I take this matrix here, matrix A is equal to, the entries are enclosed in a square bracket A, B, C, D. Each of these entries are known as element. Okay, A and B, the entries in the top row in a matrix is known as row. This is known as column of the matrix. So, matrix will have number of columns and number of rows. Let us do a quick fact check and COVID-19 outbreak globally. Yes, in the last few months, COVID-19 fulfilled all the checklists to be declared as a pandemic. Okay, let us try to represent these COVID cases in matrix form. Okay. So, when you try to tabulate the data in this format, it is called as matrix. Type of matrices. Okay. The first one, rectangular matrix. Any matrix having numbers of rows and columns is known as rectangular matrix. Okay. For example, if I take this matrix here, this matrix is having 2 columns and 3 rows. So, arrangement gives rise to a rectangular format. So, that is why it is called a rectangular matrix. Row matrix. What is a row matrix? A matrix having only one row is called the row matrix. For instance, if I take this matrix here, this matrix is having 1 row, 4 columns. So, number of entries in a row matrix is 1 by 4. So, all the arrangement in a row is, this matrix is called a row matrix. Diagonal matrix. It is a square matrix, all of whose elements except in the leading diagonal are 0. If you check this matrix here, this is a 3 by 3 matrix. All the entries are 0 except in the leading diagonal. Such matrices are known as diagonal matrix. Scalar matrix. What is a scalar matrix? It is a square matrix in which the diagonal elements are all equal and all other elements being 0 is called scalar matrix. If you check this matrix here, this is a 3 by 3 matrix. All the entries are 0 except in the leading diagonal. We also have what is called unit matrix, is also known as identity matrix. A square matrix in which the diagonal element is unity, all other elements being 0 is called unity matrix. So, this the first one I2 is a 2 by 2 matrix, second matrix 3 by 3 matrix. So, all the entries are 0 except in the leading diagonal. So, for first matrix the leading diagonal entries are 1 1, the second matrix I 3 the entries in the leading diagonal are 1 1 1. Such matrices are known as unit matrix. It is also known as identity matrix. Comparable matrices. For instance, if you take two matrices A and B, and if two matrices A and B are of same order, then the matrices are said to be comparable matrices. For instance, I take A and B here. A, it is a 3 by 3 matrix, B 3 by 3 matrix. So, A and B has same order, therefore, A and B are called comparable matrices. Okay. Let us try with the first fundamental operation of the matrix. Matrices of the same order can be added. Okay, I am taking this matrix A and B here. So, let us check whether A and B can be added or not. Check the order of A, it is 2 by 3. Check the order of B, it is again 2 by 3. So, matrix A and matrix B are comparable matrices, and A and B can be added. Okay, here we go. So, A plus B. So, matrix A and B can be added. Their corresponding entries will get added up. So, this is how your matrix addition will look like. So, A plus B. So, A plus B. So, A plus B. So, A it is 2 by 3, B is 2 by 3, A plus B will result in another matrix which is also of the same order. So, which means I think matrices can be added, provided two given matrices are of same order. Okay, subtraction of matrices. Okay, I am taking two matrices here. If L and M are matrices of same order, then we can subtract L minus M. I am taking a matrix L and M here. Okay, let us check whether this subtraction is possible or not. Let us check the order of matrix L. It is 2 by 2. Matrix M, the order is 2 by 2 again. So, therefore, matrix L minus M is possible, and their corresponding entries will get subtracted. So, this is how things will happen. L minus M is equal to 3 2 minus 1 2 0 minus of minus 2 2. So, last entries are 1 2 3 2. So, which means comparable matrices can be subtracted. Multiplication of a matrix by scalar. While dealing with matrices, I think real number are often referred to as scalar. For instance, let us check this one. Matrix multiplied by scalar by multiplying each element of the matrix by this scalar. For instance, if I take a matrix here, this is matrix A, and I want to get 3A here, 3 times A. So, this number 3 is called the scalar, and all the entries will get multiplied by 3. Therefore, so this is the resultant matrix 3A. So, which means I think 3 times A will result in another matrix 9 3 6 9. Let us try to evaluate 2A plus 3B, where matrix A and matrix B are given. Okay. This time matrix A and matrix B are given here. So, I think this is not a row matrix. A and B are diagonal matrix. So, I think we can write this matrix A as 1 0 0 0 minus 4 0 0 0 8, and matrix B minus 2 0 0 0 0 0 3 0 0 0 5. If I evaluate 2A plus 3B, where 2 and 3 are scalar here, first matrix A will get multiplied by 2, second matrix B will get multiplied by 3. Number 2 and 3 are this time is known as scalar, as discussed in the earlier slide. So, which means I think this is the value of 2a plus 3b. This will again result in diagonal matrix. Very important, multiplication of matrices. Two or more matrices can be multiplied. Okay. The product of m by n matrix A and n by p matrix B produces matrix C. So, this is how the matrix multiplication will look like. A is of the order m by n and B n by p will result in matrix C, which is equal to C is of order m by p. Okay. Let us check whether this matrix multiplication is possible or not. The prerequisite condition for multiplication of the matrix is you check the first matrix and the second matrix. Let us check the first matrix. The number of columns in first matrix is 2, the number of rows in the second matrix is 2. So, therefore, this matrix multiplication is possible. Let us check it. Note, the rule of matrix multiplication is the number of column in the first matrix must be equal to number of rows in the second matrix. Okay, let us have in the second activity. Find the product of A and B. I will take matrix A here, matrix B. Matrix A is order 2 by 2, matrix B is 2 by 2 again. Okay, let us check whether matrix multiplication AB is possible or not. In later part, we will also check whether BA is possible or not. Okay, matrix A has 2 columns and matrix B has 2 rows. Therefore, matrix multiplication A times B is possible. Okay, A times B. So, this is the product of A times B. Now, if you find BA, we will have this result. So, if you find the value of AB, AB and BA are not equal. Therefore, we conclude that matrix multiplication is not commutative, which means I think AB is not equal to BA. Application of matrix multiplication. Okay, let us have this simple problem here. A man buys 8 dozen of mangoes, 10 dozen of apples and 4 dozen of bananas. Mango costs new 18 per dozens and apple costs new 9 per dozen and banana costs 6 per dozen. Represent the quantity by a row matrix and prices by column matrix and obtain the total cost. So, we want to find the total cost involving all this list of fruits here. Okay. Let the quantity and price matrix given below as quantity given by a row matrix and price given by a column matrix. Okay. To obtain the total cost, I think we have to multiply quantity times price. Let us check whether this multiplication is possible or not. Quantity, we have 3 columns. Price, we have 3 number of rows. So, therefore, matrix multiplication Q times P is possible. This will lead to the final cost, the total cost. So, total cost is equal to term 258 only. Okay, next, very important, taking the transpose of a matrix. Okay, how do you find the transpose of a matrix? A matrix obtained from any given matrix A by interchanging its row and column. Thus, if the order is m by n, then the order of the matrix after being transposed becomes n by m. For instance, if you find the transpose of this given matrix, A is given here, A is equal to 3, 5, 7, minus 1, 0, 2, 4, 6, 1, what will happen? You just change rows into columns. So, when you just interchange rows into column, we have 3, 5, 7, minus 1, 0, 2, 4, 6, 1. So, this is how to take the transpose of a matrix. We will also discuss some of the properties associated with the transpose of a matrix. Okay, property 1, if A is a matrix, then you take the transpose of A and you take transpose one more time, this will result in A. It will result in original matrix A. Property 2, if A and B are two matrices of same order, then A plus B, then take the transpose will lead to transpose of A plus transpose of B. Property number 3, if A B of transpose, if you take the transpose of A times B, this will result to product of A and B in the reverse order. So, B of transpose times A of transpose. Property number 4, if A is a matrix and K is some scalar, then you multiply matrix A by K, take the transpose, this will be equal to K times transpose of a matrix. These are some of the properties associated with transpose of a matrix. Let us have some more activities. Okay, I am having matrix A here and matrix B here. So, I want to find A times B and then find the transpose. Okay. Let us check first whether multiplication of matrix A times B is possible or not. Matrix A has 3 columns, matrix B has 3 rows. So, therefore, matrix multiplication A times B is possible, which means we can take the transpose of product of A times B. So, A times B. So, this is the result in here. So, we have A, B and then take the transpose. So, this. Okay, next let us discuss the procedure to find the inverse of a matrix. Step 1, check whether the inverse exists by finding the determinant of A. The condition here is the determinant will exist if and only if determinant of A is not equal to 0. Step 2, interchange the entries on the leading diagonal and change the sign of the entries on other diagonal. This may be applicable to 2 by 2 matrix. Step 3, divide the result of step 2 by determinant of matrix A. So, this is how finding the inverse of a matrix will look like. Okay. I am going to take a matrix A here. If A is equal to this 2 by 2 matrix 1 3 2 minus 1, find the inverse of A. Okay, fine. Step 1, find the determinant of A. So, determinant of A. So, this time it will not be enclosed in the matrices. So, determinant of A is 1 3 2 1. So, it is equal to minus 7. So, therefore, inverse of A do exists because determinant of A is not equal to 0. We can proceed on furthermore, find the inverse such that you change the entries in the leading diagonal 1 minus 1, just change it. So, it becomes minus 1 1. Other diagonal 3 2, just interchange it and just as a negative sign. So, this is how we obtain the inverse of given matrix. So, for 2 by 2 matrix, finding inverse is very easy. Activity 5, the cofactor. Finding cofactor of the matrix is going to be very important when you study some of the application of the matrices. Okay, I am going to take a matrix here. If A is 3 by 3 matrix, find the cofactor of 8 and 10. Of course, if you have to find all the cofactors here, we have to find 9 cofactors. So, we have to find the cofactor of 8 and 10. We are not going to find the cofactors of all the entries here. The cofactor of 8 is, cofactor is usually denoted with capital letter A subscript ij. The position of A in the matrix is A subscript 23 is equal to minus 1 to the power 2 plus 3, and the minor, when you take number 8 here, the minors are 2, 1, 2, 9, 10. So, this is adjusting sign and finding the product and all. I think this will result in the cofactor of 8 is 8. So, minus 1 to the power odd power 5 is minus 5, 10 minus 18 is minus 8 is equal to 8. Next, cofactor of 10. In the matrix, the cofactor, the position of element 10 is corresponds to third row and second column. So, cofactor of 8 is equal to minus 1 to the power 3 plus 2. So, minors are 1, 4, 5, 8. So, is equal to minus of 8 minus 20. So, minus 12. So, this is how we find the cofactor of a elements. In this case, if we have to find all the cofactors, I think we have to find 9 cofactors. Adjoint of a square matrix. Okay. Adjoint. Okay, I am going to take a matrix here. Matrix A, all the entries are given A 1 1, A 12, A 13, A 21, A 22, A 23, A 31, A 32, A 33. So, adjoint is denoted by, so you take all the cofactors of all the entries, replace, form a new matrix adjoint A, and then take the transpose. When you take the transpose, the rows will change into columns. So, this is how adjoint of matrix A will look like. Okay. I think we are coming very close to the end of the lessons. I think finding the solution of a system of linear equation. One of the application of matrices is it is used in solving the system of linear equations. Okay, if you take a system here, systems of equations, A x is equal to b. First, we need to find the determinant of A. For instance, if determinant of A is equal to 0, what does it mean? Unique solution or system is said to be consistent. Therefore, x is equal to A inverse of b. So, therefore, the system of linear equation have a unique solution. In case if determinant of A is equal to 0, it could be no solution or infinite number of solution. Proceeding further, if find adjoint of E times B, and if you find that adjoint of A times B is equal to 0, there could be no solution, or if adjoint times adjoint A times B is equal to 0, infinite numbers of solutions. Okay, what if the system of linear equations have unique solution? Let us take a graph here. I will take a system of linear equations here. Okay, if these systems of linear equations have a unique solution, they will have a point of intersection such that that point of intersection will satisfy both the equations. Unique solution, or call it the system, is said to be consistent. Otherwise, if the system of linear equations have no solution, so this is how the solution will look like. You can stretch this graph and it will come out of the screen. I think this two lines will never intersect, which means this system of linear equations have no solution at all. So, no solution, or the system is said to be inconsistent. Sometimes the system of linear equations can have infinite number of solutions. Let us see how this graph will look like. I have a red line to represent the first equation, green line to represent the second equation. So, these two lines will touch at many points. So, which means these two lines, when they have point of contact on many places, I think we will have infinite numbers of solutions. The system is consistent, but having infinite numbers of solution. Okay. Application of the matrices to solve linear equations. So, we can use matrix to solve systems of equations. So, for instance, I am taking this equation here. First equation is a linear equation, second equation again it is a linear equation. So, first one, so given equations are equivalent. So, this coefficient of the x and y can be extracted and can be written as a matrix A. Second is a column matrix. Take the variable x and y is equal to, result in column matrix, take the constant term. So, this is equal to, actually A x is equal to B. So, A x is equal to B. So, A, this is matrix A, matrix X, matrix B. Matrix A formed by extracting the coefficient of x and y. Matrix X, two variables involved in a system of linear equations. B is column matrix, is taken by formed by extracting the values, constant values of equations. So, first try to find matrix determinant is not equal to 0, 37 is not equal to 0, there definitely there is a unique solution. Proceed further and try to find the adjoint of A. I think we have also already discussed how to find the adjoint of a matrix, adjoint of a matrix. To find the adjoint of a matrix is equal to find all the cofactors and take the transpose. So, next inverse of a matrix. So, therefore, solution of the linear system of equation is x is equal to 2 and y is equal to minus 1. So, if you sketch this system of linear equations on a graph, this is how the graph will look like. So, first equation, solutions to system of linear equations. The first graph, 4x minus 3y is equal to 1, 11. Second equation, 3x plus 7 is equal to minus 1. So, this is the point of intersection of system of linear equations. So, this is the solution. So, this corresponds to x is equal to 2 and y is equal to minus 1. Okay. I have designed some activities for you. Complete the following exercise, so that you have a better understanding of this chapter. Okay. Question number 1, find x and y such that I think this is quite direct. Question number 2, find the inverse of the matrix. I have the given matrix here 1, 2, 3, 4. So, you have to find the inverse of the matrix. Question number 3, I have a set of equations here. So, we have to find the solution to this system of linear equations. So, before I end the lessons, let us try to recollect what we have covered in this lesson. We have studied about the type of matrices, order of matrices, operations associated with the matrix like addition, subtraction of the matrices. We also did study the multiplication of the matrices with the scalar, multiplication of the matrices, adjoint of a matrix and inverse of a matrix, application of the matrix multiplication, use of matrices to solve simultaneous linear equations in 2 or 3 unknowns. Okay. Thank you so much. I hope you enjoyed learning this lesson as much as I enjoyed delivering this lesson to you. Thank you.